everyone, how are you doing? Yeah, it's like, I know it's the end of the day. It should be like more intimate. We should all go around and talk about what we like about Alexa, right? What's our favorite skill? Welcome to ALX317. I am Dave. I'm on the Alexa team, and I have brought with me Eric from Capital One. And how many people here have an Echo Show? Oh, okay, great. How many people here know about an Echo Spot or have ordered an Echo Spot? Okay, cool. So everything I'll show you today will work on both of those devices. How many people here have an Echo? All right, almost all of you. Okay, so what we're going to do, I thought it would be really neat to not only talk about the Echo Show and the whole idea of voice and visual, but what I'm going to do at the end of the talk is we're going to code a skill, and then we're going to go ahead and update it for the show. And you'll have access to all that code later on if you want to download it and check it out yourself on your own devices. And then what Eric is going to do is he's going to talk about the Capital One skill. How many people here have used the Capital One skill or a Capital One customer? Okay, awesome. So the Capital One skill has been updated to work both on existing Alexa devices and the new Echo Show. So rather than hearing it from me, the Amazon guy, I thought it would be really cool to hear it from the head engineer, Eric over here, of how they've actually built something real versus my hello world stuff. Okay, sound good? All right. And I'll be around afterwards. If you have questions, you can hit me up on Twitter at @TheDaveDev, and I'm more than happy to answer any of your questions. So you may have heard some of this week, that we are now over 25,000 of these skills, and I see some faces out here. I know some of you have written skills, so thank you. You make Alexa smarter every day. One of the things I do in my role as the chief evangelist is I collect feedback from all of you, from customers, from developers, from brands, about what we need to do to make Alexa better. And so what you see up here on the screen is just a URL to our blog, and you can check that out at any time of some of the things we've announced. So what I thought would be neat is, since my talk last year at reInvent, what are some of the things that we've actually launched and we have in the hands of all of you? So the first thing, and I'll show this a little bit later on, is a skill builder. So the skill builder is a graphical way to build Alexa skills now. You used to have to copy and paste into web forms on our developer portal. We've now opened this up with an API that we call SMAPI, or a skills management API, and we have a visual way for you all to start with conversation, so you can actually type in what a human being is going to say, and then work your way back into creating this interaction model. So in other words, the contract for conversation that your Alexa skill will have, and that's free for everyone. We heard from all of you as developers as well as customers of, hey, Amazon, it would be great if Alexa skills could access my shopping list, or I could use a to-do app like AnyDo or Todoist on my iPhone and Android device, and then have my Echo be able to add to that. So we've added support for that. We've extended the Smart Home API, and you may have seen some of the talks this week about how we're now doing everything from thermostats and lights to door locks, and you have the ability to tap into that API without creating your own interaction model. We have speech cons and whispers. So part of the experience of having a conversation with Alexa is to have her not always sound the same. How many people here have used a skill and every single time you use it, it's the same answer, right? It gets pretty boring very quickly. So what speech cons do is it gives you the ability to change the way she pronounces. It gives you the ability to have her whisper, play sounds, and even do emphasis. So if I said something like wowzer, she'll go wowzer or bazinga. And so it makes it very personable instead of just the same thing all the time. Device location is something we heard from customers and you is, hey, if I want somebody to have access to the zip code or the street address that I put in that Alexa app, I want a skill to be able to do that to show me local deals or to be able to order groceries and things like that. So device location is now in there. Last year at reInvent, we announced a built-in library, which in essence is Alexa knows about all the things. So she knows a person has a name, and an address has a street, and a country, and a zip. So we've added all of that, so you don't have to teach her about those things. And then what I'm going to show you today, and what we're going to talk a little bit about, is display templates. So the ability to show information visually in lists, to be able to scroll by both touching the device and to use your voice. A camera API. Does anybody here have like a Ring doorbell or anything like that? It also works with a baby monitor. So I have this in my house where I can say, Alexa, show me the front door. And on my Echo Show, it shows the Ring camera for my front door. So the ability to integrate that in a smart home API. New devices. So you may have seen, we talked about the Echo Spot. There's a new version of the Echo, and there's also an Echo with a smart home hub. And in our State of the Union, we also showed a lot of these AVS devices. So I actually have, it's like a little Echo Dot. It's like this big. It's called Garmin Speak. So I got sick and tired of hearing myself say Alexa when I was driving my car. So now I have this Garmin Speak device when I actually say Alexa, she answers. And it works off your cell phone connection. It's pretty neat. We've launched in the UK, in Germany, Japan, and India now, and all that is available on the Echo Show and through all of our tools. And you may have just seen the blog post announcement that went out for Australia and New Zealand. So that will be coming soon as well. And we've also had Canada. Canada is a recent one where we've launched. Voice profiles, so the ability for my voice to be detected as a human being. So for example, in my house now, when I reorder something off Amazon, it does not ask me for my passcode because it knows it's me. My kids still have to give the passcode, and they don't know what the passcode is. Push notifications, so we announced this week that is open to developers, as well as the ability for voice profiles in Alexa skills will be coming. And then I mentioned SMAPI and the Ask CLI. We've also just announced the Alexa Gadgets API, so you may have seen some of those buttons here at reInvent that gives you the ability to push a physical button, have it integrated with Alexa, and then AWS services like Lex, where if you're using a chatbot within your organization today, you can go ahead and you can output that directly to an Alexa skill. And then the ability to play video. So some of you may have already seen this, like if you're a Dish customer, the ability to control your TV, to select a certain channel, or if you've got a Fire TV and you have an Echo in your home, you may not know this today, but if you talk to your Echo, you can control your Fire TV. So all of that is happening through a video API, and those are just some of the things that we've launched based on all of your feedback over the past year. So thank you. Please keep that feedback coming. Let us know online. Feel free to email me. Hit me up at the conference. We want to continue to innovate and make life easier for all of you. So Echo Show, this is my fifth reInvent. This is my third year talking about Alexa. And I get hit with questions like this. Dave, you've talked about conversation and everything's about voice and speech, so why is there a screen, right? And it's funny because when you think about it, we've been trained over the past 10 years that when there's a screen, we touch it. Because we all have these iPads and iPhones and Android devices. But that's not what this is. This is something completely different. This is a voice-first experience. This is a device that's on the other side of the room, and I'm doing something. Maybe I'm cooking, maybe I'm working on my computer, and I ask a question. So maybe I say, Alexa, give me a recipe for chicken. And it shows me a bunch of recipes on the screen. And then I can say, Alexa, scroll right, or Alexa, scroll left. So it's just like I would navigate using touch, but I'm doing it completely with my voice. And when I stop talking to the show, if you have a device, you've probably seen this, what's on the screen will slowly fade away, and it will go back to the home screen. So there's no, hit the home button, and that's how you exit an app experience. And so it becomes this conversational, voice-driven experience with visual information you can present in addition to what's being said. And as human beings, in order for us to process auditory information, we have to process the entire thing. Visual information, we can kind of block things out that are under the fold, right? That's why we've built interfaces with tabs and little carrots that we can move information around. And so you're going to want to design these things, and you'll see this when Eric talks about Capital One, is that when Alexa responds, she may be very brief. In fact, you don't want to say a lot of things, but you can display much more information on a device with a screen. Make sense? Okay. So with that, I will have the Capital One skill and Eric talk about all of the great work that they've done. Thanks, Eric.
Thanks, Dave. Good evening, everyone. Again, I'm Eric Miles. I'm a director of software engineering at Capital One. For those of you who weren't here last year or didn't know a Capital One skill existed, first I'd like to talk a little bit about the Capital One journey, sort of how we got where we're at and why we got there. Then a little bit about application architecture, this idea of supporting device screens, multimodal, as well as multiple platforms. Dive into that a little bit and how we do that at Capital One. Then we'll get into some best practices for using the display directive APIs and some things we learned across the last several months while we started building out the support for the Echo Show. And then I'd like to get into evolving from customer feedback and sort of how that drives into our voice design lab and development team process. So first, the Capital One journey. In 2015, in June, we had a couple developers go out and purchase some hardware and started playing with Echo shows, and the Echoes, and realized that pretty slick hardware and really interesting, and wondered what we could do on the platform and get to our customers. We are a technology company. We like to be where our customers are. And so we really started creating an MVP, which is account pairing, and really our basic piece of functionality, which is, what is my account balance? So we partnered with Amazon, some platform enhancements and continued work, and we eventually launched at South by Southwest in March of 2016. Then the rest of 2016 was dedicated to expanding our skill, broadening business functionality. That summer we released support for financial services, so you can ask for your auto loan payoff quote, the account balance, pay your auto loan payment. And then in the fall of 2016 at Grace Hopper, we launched what we call spend analysis and enhanced transaction search. So the ability to ask, what did I spend last week at Amazon? Or what did I do, how much did I spend last night? And then 2017, primarily we were focusing on the Echo Show launch in in June with Amazon. So why did we do this? We really wanted to test this channel out. It was something new for Capital One. It was easy for us to get into this channel. We knew virtual assistants were coming, and this was an easy way to get into this channel to test some of these things out. So we were doing test and learn, putting some stuff in front of customers and seeing how they thought. While we were doing development, we started doing some research. And we found out from our customers that they really liked the experience, the hands-free experience. They were interested in getting access to information such as account balances, interest rates, transaction history, and they were open to performing some transactions like paying a credit card bill or transferring money. But there's always concerns. So there were some security concerns. So what we did there is we created our account pairing experience to look identical to our logins for our web app and for our mobile apps, and using the same API, so there's some comfort there and some familiarity. They were uneasy about the lack of physical privacy. So again, you have a contractor in your house, maybe you have a guest over, you got these echoes and dots all over the place. They can get access to your Capital One skill, get access to your financial information. So what we did is we implemented the idea of personal key, and we periodically query a user to give them a personal key that they've set up during account linking. And so it helps give some assurance that who's using the skill is who paired their account. And then this idea of, well, what if I mess up? How do I undo what I did? And what we did there is we really put some guardrails in place, some limited use cases, mostly informational. Really one transactional item, at least currently, is pay bill. And we put some guardrails around that. You can only use a previously set up pay from account that you've set up on our website. So our focus here, what do customers want from their bank? Well, we had an idea what they wanted from their bank, but the real thing that we didn't know is how are they going to ask for it? And what we found out that this really falls into two separate buckets. One, help me perform a task, or two, financially speaking, am I okay? Help me perform a task. You can think of some of those transactional items, transfer money, pay a bill, identify a fraudulent purchase, pay my credit card bill, things like that, or order a new venture card. Financially speaking, am I okay? Are those informational functions? What is my account balance? When is my next payment due? How much available credit do I have? What did I spend last night? So now let's talk about application architecture. This is, this is really important for us to support the notion of multimodal, so the introduction of a screen, as well as for us, for at Capital One, and probably for other enterprises, the notion of supporting multiple platforms. Now, I want to qualify this discussion. This is really an enterprise-grade solution. You're creating your first skill, and you've seen probably lots of sessions this week. You don't need these sort of things. You don't need these patterns. You don't need these abstractions. These are concerns as you move into the enterprise when you need to start thinking about multiple platforms and multiple devices. But when you create your first skill, or for your hobbyists, go use Lambda. It's really easy, and use the things that you've seen this week. However, for the complexity for us of multi-platform, multimodal, we've tackled it via solution architecture. So we found that in these turn-based reactive messaging platforms, they all seem to have the same paradigm with intents and slots. And through this paradigm and through the evolution of our skill, we've created something that we're calling the conversation factory, which is just a series of abstractions and patterns that we can apply to all these solutions to get the most reuse out of our code base. So you can see on screen the gray block where it says Capital One skill. And we've got a bunch of these stacks of our application. In reality, our conversation factory is that one, the bold blue that says interaction adapters. And this is where, in reality, when we introduce a new platform or we introduce a new device or a new display that we have to support, this is where our work happens. None of the other code is really not touched. And again, this isn't like a magic SDK. We didn't use some special library. It really just boils down to solving an engineering problem using solid engineering principles. Architecture and software design, abstraction, encapsulation, and separation of responsibilities. So let's talk about those patterns and abstractions first. My team, the team that's responsible for our skill, is a Node.js shop, and we do use Express.js. We have a bunch of other middlewares, things for logging, things for security, but ultimately there's an intent middleware that's responsible for routing an incoming request and intent to an intent handler. We have a one-to-one mapping between intents and intent handlers. That intent handler will call something, a component called the adaptive factory, which is responsible for creating the appropriate platform-specific interaction adapter. It'll interrogate or take a look at the incoming request, the URL, maybe some HTTP parameters, and create the interaction adapter. The interaction adapter for us is really the heart and soul of our conversation factory pattern. It abstracts out the interactions required to obtain information about the incoming requests, things like user context, intent, slots, as well as abstracts out building those responses for displays and for voice, and ultimately sending back to our customer. It also has accessors to a couple other factors we use within our skill. We have something called a display factory, which is an interface for creating platform-specific displays. And we also have a speech factory, which is an interface for creating platform-specific SSML. And then ultimately, once we instantiate the interaction adapter and the appropriate factories, that interaction adapter is then sent over ultimately to our intent handler, which is responsible for orchestrating our back-end API calls, and then sending a response to our users. People have love-hate relationships with class diagrams, but they're really a great way to get a quick look and look at the structure of some objects or some classes, as well as some relationships. So first we talk about the speech factor, and it's probably misnamed. We should probably call it the SSML factory, because it's really responsible for creating platform-specific SSML. Now, while SSML is a standard, we found that platforms support this standard differently. So we had to create implementations for the specific platform that we're supporting. We do have a method for speak date, and then something for us, we have speak last four, which is when we give you a list of accounts, we'll identify the last four as a unique identifier for the accounts. So we'll say your venture card ended in 1, 2, 3, 4, your Quicksilver card ended in 4, 5, 6. Without SSML, Alexa would say your venture card end that's 1,234. So SSML allows us to do that. And the other thing I want to highlight here is, and you'll see this in the other class diagrams. Again, we have one for Alexa, and we have one for the other platforms we're either supporting right now or we explored supporting in the past. This is a display factory. Again, this is for supporting platform-specific displays. It's really use case-centric. We don't have any channel information, platform information here. Just doing show transactions, show O, and we're passing around our model objects and our data really to support the display itself. And then again, sort of the heart and soul of the conversation factory, the abstract class interaction adapter. And so we have pulled out a lot of the common functionality across these different platforms and put in this base class. And then we defer to the implementing classes to provide an implementation specific to that platform. So for Alexa, there's a specific way to get out the intents, the user context, the slots. Same things for the other platforms. And again, we didn't come out with this with our skill when we first originally launched. It's been an evolution. And it really started when we started looking at other platforms and supporting other platforms. Then we introduced the interaction adapter. We introduced the SSML, the speech factory. And then as we started looking at supporting multimodal, we were already looking at some other channels support there. And then when the Echo Show came along, it really made sense. It just naturally fit within our abstractions. So we're going to look at a little bit of source code here. And I know I said we're a Node.js shop, and then the first piece I pull up is a TS file. If you're not familiar, this is TypeScript. And what TypeScript is, it's a type superset of JavaScript that compiles into plain JavaScript, eventually runs on Node. The great thing that it supports is TypeScript, is strong typing, as well as some object-oriented constructs that we're really used to, coming from somebody who has a Java background, interfaces and classes. And it's really been great. It's allowed our team to really develop and create some high-quality code. And as well, it was leveraged when for our Echo Show work, and we'll get to that in some subsequent slides. But again, this is a speech factory, really simple again. Speak last for, speak date, and again, no platform-specific information here, just data that's being passed around. And our display factory, again, same thing, interface, very use case-centric, passing around our model objects and our data. Nothing platform here. And here's our abstract class for the interaction adapter. And believe me, a lot of code's cut out here, but wanted to show you that we do have some base functionality that's supported across all the different implementations. Some members like speech. We borrowed ask-tell from some other SDKs that maybe you're familiar with working. The notion of ask, so if we present something to our user, we're going to keep the session open for our prompt the user for a response. Then we have tell, where we provide a response and we may keep the session open depending on how they originally interacted with the skill. And then again, we defer to all the implementing classes for the platform-specific information like get intent, get argument, state, user context, etc. Here's a quick look at our Alexa adapter, and again, quite a bit of code has been cut out here. But I wanted to sort of hone in on where we instantiate the speech factory and the display factory. Right now, we only have one speech factory, we only have one display factory, but we could at runtime interrogate the incoming request and maybe create a different display factory. Maybe we'll create an Echo Show display factory, or maybe an auto display factory, depending on exactly what display we're catering to. Maybe we need to do a different speech factory, so maybe we'll actually do a different voice experience depending on the incoming request. This is all done at runtime. This is something we swap out just based off of interrogating the incoming request. And this is a look at our account balance intent handler. And you can see here the first line, we do pass in an instance of the interaction adapter. It's not typed to any specific channel. And then the first line, you can see adapter get argument last for. So here we're interrogating the incoming request to get the last for slot, if it exists. Same thing on the next line. Adapter get argument, we're going to get out the product type, slot type if it exists. And then the next line, we're going to call some backend APIs. You can see accounts, get account. And we're going to, again, interrogate the adapter for getting the user context. Again, we abstract out this idea of user context so we could leverage throughout our skill in a non-platform specific way. Capital One, in the last few years, has really followed in Amazon steps, APIs everywhere. And so the same APIs that we leverage on our mobile channels, so our Android app and our iOS app, as well as our web apps, they all use the same APIs, the same thing that we're using here in the skill. So we've got a little service layer that we call these backend APIs, but we do some slight caching, so we don't have to do multiple calls. But we have a little service layer here where we go and get our data. And then we get down into the build account response. And again, I want to point out the first line here, adapter, get display factory, show account summary. We're passing in an account list and a currency type. There's no channel specific information here. So we can add new platforms, add new displays, and again, we're going to defer to the implementation of what they do. And we may have a platform or a channel that has no display, and it may be essentially a no op here. It's just going to take in the data and ignore. And then finally, just to show the speech factory in use, this is our account model class. We have a little helper method called toSpeech. We pass in the speech factory, and you can see on that first line there, speech factory, speak last four. We pass in our last four value, and ultimately it sends out the representation for how to say last four. Again, we cut out some code here. Sometimes we say things a little bit differently, whether it's a bank account or an auto loan account. So let's talk about some of the best practices for using display directives. Handling the screen-based intents posed a small challenge for navigation for our skill. We really have a flat navigation model. It's something we did on purpose. With the exception of our pay bill, where we have a multi-step conversation, everything's pretty flat, so you can jump from one intent to another. So adding the screen back into the mix sort of felt like we're adding the need for some traditional navigation models. So how do we support this? Rather than having to carry state around all over the place, we leverage the token field that's in the template for selection events. And what we did is we use a value, a delimited field, where we use the next intent plus an ID. So for example, clicking or selecting an account will take you to the account balance screen, and then we'll have our delimiter, a dash, and then the last four. Or selecting a transaction, go into transaction details, it'll be transaction details dash transaction ID. The back button posed a little bit of an issue for us, mostly because it was an 11th hour ad, but again, due to our flat navigation model, it really didn't make sense. It was more of a breadcrumb. So rather than shoehorn it in, we actually worked with Amazon and they disabled it, or allowed us to disable it. So we don't have back button support in our skill. This may be something we revisit in the future, but honestly, it doesn't make a lot of sense for at least the way our skill is currently designed. TypeScript, we leveraged heavily. Being a launch partner does have its perks, but it also posed some challenges. It seemed like the template specification changed weekly. And as we approached the launch date, it actually felt like it changed daily. I'm sure it did, and it was probably weekly. But since we're already leveraging TypeScript for our own models and interfaces and for some of our included modules, it just naturally fit. So we modeled all the templates and as many constraints as possible as we could through TypeScript. So when those structures changed, they're identified in the IDE, or they would fail compilation process in our CI/CD pipeline. So a quick TypeScript example, you can see we had a base template structure, then we defined a body template, and then we defined body template 1, body template 2, 3, et cetera on. And we put the structures in that were supported for each of those templates. Again, so if that structure changed, we'd find out in the IDE or during compilation. And same thing with list templates, base list template, and then list template 1, 2, 3, et cetera. Another example, so again, not only did we try to define structure, we try to define constraints. You can see on the second structure, the text content, there's three members here: primary text, secondary text, and tertiary text. Primary text is required, and the secondary and tertiary text are actually optional. That's identified by the question mark there. So again, try to define constraints in there as much as possible. And the same thing with some of the values. So on the text field, you can see the type. There's a text field type, and that's essentially a enumeration of what values that it could accept. Something our designers were really cognizant of up front was trying to be consistent across all of our screens. So the primary text area on our account balance screen, the text there had the same styling, the same font size, the same weight as our primary text for our pay bill confirm screen or some of our other screens. So because of this, we could extract out our markup into helper functions that we could leverage across all of our screens. So when the specification did change, we could go change them in a function, a supporting function, and they're changed essentially all of our screens. So something to think about. Definitely try to do some code reuse across your screens. Try to make your screens as similar as possible. And just a quick example of some of those markup examples. Small tag, big tag, normal tag, bold tag. We had a whole bunch of these, but we go into one place, we change them, and they would appear on all of our screens. So pulling it all together, this is our show transaction detail function for one screen. You can see at the bottom where I've highlighted here as Alexa body template 3. We're essentially telling TypeScript, hey, this should be a body template 3 structure. And starting from the top, we have our back button. We've hidden it. We have our optional background image where we have our capital 1 background. And then we specify an image and the structure along with that, content description and log source URL. And then we get into the text content. And remember, secondary text and tertiary text were optional, but here we only have primary text. And you can see here where we use some of those helper functions to essentially concatenate a bunch of markup here for display purposes. Now I want to quickly talk about our skill in evolving from customer feedback, because it does drive into our design process. It's a big driver of it. We do collect feedback on CapitalOne.com. We formalized page where you can go in and put in some feedback there. We do collect feedback on Amazon and the skill store. We hope that Amazon will give us an API for that. So right now we have an automated bot that runs on a schedule that does some screen scraping, but we do collect feedback there. And then we also collect feedback in social channels. So we monitor Facebook, Twitter, LinkedIn, and we also collect feedback there. All this gets put into our backlog and prioritized by our PO. And that roadmap, our product roadmap does address customer feedback. So new feature requests. Again, we launched it to South by Southwest in March of 2016. One of the first feedbacks was, hey, this is great, but I'd like to get my auto loan information. So again, that drove the notion, that drove the release of that functionality that summer. And then feature enhancements. So we went out with pay bill launch, and then we had some feedback like, great, I can pay my full balance or my minimum payment, but on some of our other channels, you can do custom amounts or your statement balance. So again, feature enhancements there, we eventually rolled out with that functionality. And then platform enhancements. We had personal key and it was fantastic, but if everybody's familiar with the companion app in the history, those utterances show up. So it's great that we have this personal key and we're preventing others from using a skill and getting your information, but should they look at your phone, they can find your personal key and now they can go to your skill and get that information. So we actually worked with Amazon on this. We came up with a solution that allows us to obfuscate or hide some of those utterances, and hopefully some other developers got some use out of that as well. So our voice design process, again, feedback drives our feature development, as well as our partners, our lines of businesses that come to us and want to put something onto the skill. And this is really divided up into 4 phases. The first phase is our product owners and our designers getting together. They state a hypothesis, they state a testable predication, and then they build voice interaction prototypes, or I shouldn't say voice interaction, all interaction prototypes. That may be using the voice simulator within the test tab of the developer portal. It may be a small throwaway skill just to get some multi-turn conversations. We use Kindle Fire. We might put some screens on there. I actually had one designer tell me he was using cardboard and drawing on mock-ups to put in front of customers. Well, we create some prototypes that go into phase 2, where we actually bring our customers into our user labs and we do some research. We put these prototypes in front of them, we collect feedback, we figure out how they want to speak to the skill, how they want to hear the skill talk back to them, and we take that information and that goes into phase 3, where we create some insights. We gather that research, we ideate, and that's where we really generally define what our feature is going to look like. And then that goes into phase 4, which is the actual prioritization, put it into the backlog, implementing and releasing. Which is actually interesting. As a software engineer, I only work in that mostly in that upper section of phase 4. And there really is a lot of work that happens before that with product and design and customers through those other 3 phases. So how did our design team approach the Echo Show skill? Is, we were a launch partner, so in our initial meeting, pulled us in, we started talking about it, and we didn't have a lot of information, so we had some questions. Should screens simply supplement the voice experience, or is it a primary experience? And as Dave mentioned earlier, it's a secondary experience. It's a supporting experience. Voice is still primary. What's going to be a user's reaction when there's a screen present? Are they going to start engaging with the screen, or are they going to still engage with the voice? And how are we going to use this screen? What unique functionality and interaction models should the screen have? Amazon answered some of those questions for us. Again, voice is the primary experience. They gave us a set of templates that we could use to render our things on the screen. These answers raise more questions. Okay, so we have these templates. How can we create a unique experience? How can Capital One differentiate their skill from skill A and B in the skill store? Or better yet, how can we differentiate our skill from another financial institution that's in the skill store? And within these templates, how can we design customer information with those constraints? For banks, the traditional way of displaying data is in this centuries-old ledger approach, and we really didn't want to do that. We wanted to stay focused on the important things that the customers ask for. Or what other contextual information could we display when a customer asks for account balance? What's too little? What's too much? What's really helpful? So again, since we're a launch partner, we really couldn't discuss too much of this with our users before launch. But post-launch, we did do some user lab sessions, and we had some confirmation of some things that we thought up front, and Amazon's also confirmed as well as some things that we didn't know that we were going to find out. The biggest learning we found, and Dave mentioned this, is that what people are hearing and what people are seeing do not have to be the same thing. So we can actually give them more information on the screen, and they can consume that much easier than what they can via voice. And for us, while it's important to be accurate with our financial institution, we can't screw up numbers. Providing too many numbers can be cognitive overload. So what we do here is, when you ask for a specific experience, you still get that same voice experience, but we, again, provide more information, sort of supporting that first point. You ask for account balance, you're going to get the account balance voice experience, but we're going to show you this screen that you can see up on the slides that'll give you your account balance, your available credit, and your due date. If you're talking about a card account, we can show you some card art. If you ask for your available credit, we're going to give you the available credit experience. You'll only get the available credit numbers, but again, we can show the same screen. So again, going back to screen reuse. And then we also found that, that the screen helped in multi-step experiences. The display really served as a cognitive anchor for people to navigate and to simplify those use cases. It really helped guide them through those experiences. And one interesting thing that we found out that we didn't expect is that while they would initially engage with the skill via voice, they tend to finish those multi-step experiences on the screen itself. And speaking with some other Amazon folks, they said the same thing. People tend to gravitate and move towards the screen. So it might be sort of some behaviors that die hard rather than completely using the voice. So that's it for me. I'm going to turn it back over to Dave, and he's going to show some of the templates and some of the things we had to implement for an Echo Show supported skill.
Great. Thank you, Eric. And this poor guy flew out from the East Coast on a red eye, and he's got a cold, and he's up here. So thank you. I thought it was important for all of you to see some of the work that they're doing. So thank you, Eric. So those of you who've created an Alexa skill before, this is what's new in order to take advantage of the visual templates that we have. So we have this event object that comes across in your Alexa request post. If you're using Lambda, this is what we'll parse out in Lambda. If you've been doing Alexa skill for a while, you've probably seen the supported interfaces object before. We've had the audio in there, the audio player as a supported interface. So if you've done full streaming audio or anything like that. What we've done for the show is we've now added display, and we've added video app. So if the device is capable of playing video, so like an MPEG-4, it supports HTTP live streaming, or you could just throw video in an S3 bucket. We've seen some brands, in order to do animation, they've actually generated from animation videos on the fly, stored it up in S3, you point to the S3 bucket, you bring it down in your response object, and then you got some cool, neat video animation, kind of like the early mobile days where you would see a lot of that happening too. So the call that you're going to make on display is render template. And these are some of the templates that you heard Eric talk about, where Capital One abstracted that and created their own display factories for those things. And so we have both body templates, and that's for using images and text in different types of orientations, as well as putting things in list, where you can have primary, secondary, and tertiary information, and then displaying video. So this is kind of what you get for lists. So vertical and horizontal. We've got two of them, list 1 and list 2. Now what's neat about this is they work both as a voice-driven conversation, so I could say next page or Alexa scroll left, as well as what Eric talked about. And it's interesting, I find myself doing this when I shop. If I ask for something, I'll see it, and then I'll walk over, and then I'll touch the thing. I don't know, it's just, I guess because I'm used to ordering on my phone. Like you said, it's a hard habit to break. But we support all of those automatically in the templates. So you don't have to worry about any of those events. The difference is, because you can separate the voice between the visual, if you've done Alexa skills before, you know that voice is driven by intents and slots. Visual is driven by something called tokens. And so those tokens, you can think of them just like if you're using div tags in HTML. It's the ability to know which visual element has been selected, and that element can be selected both through someone speaking as well as someone touching, but it'll still be handled the same way through a token. Body template is 1, 2, 3, 6. Don't ask me where 4 and 5 went. This is what we came up with in the engineering team. The body template 1 will give you full text images, and so what I'm going to show you here, because I like to live a little dangerously, I'm going to try and code it here. We're going to do a space trivia fact, so I'll ask for a fact about space, and then we'll be able to see that. We'll do a body template 1, and then we'll add an image to it from an S3 bucket. You can also create, think of it like a Word doc where you have your image on the left or right, and then you have some text flowing around it. That's what 2 and 3. 6 is really that multimodal experience that Eric talked about. So think of it like a recipe where I'll get a main list, and then I want to navigate to another page where I have more information, and that's where you would use body template 6. Here's some examples just to show you what they look like. This is on our developer portal. It's all about cheese. I'm sorry if no one's eaten yet. You're probably thinking about cheese and wine in this, so this will give you like pairings. What you see here, so this is pretty neat. If you have an Alexa skill today, you may notice up here, everybody see right here the icon? So you don't have to do anything for that. If you already have an existing Alexa skill and somebody uses your skill, even if it's not using the render templates, your icon will show up on the Echo Show device. And then you also have the ability, if you didn't use the render templates, it would be the title for your Alexa skill up here. So I'm getting a piece of information, and then what you're seeing here on the right is because the actual text of the body is larger than the screen, after a little bit, it'll automatically start scrolling. So again, I don't have to go up and touch it. I can see the information. By the time I'm at the bottom reading, it'll start to scroll up. Or I can ask Alexa to scroll down. Here's a template 3. Body template 3, you can see we got an image on the left, we got some text on the right. This happens to be template 1. So this is using a full background image, and that's what I'm going to show you. So think of something like, I don't know, if you make a flashcard skill, or a skill about a sports team, or maybe like animal trivia, you could just show a nice big picture, and we see that's very common in some of the Echo Show skills. This is the list, and notice here you'll see I have primary information, and then I have secondary and tertiary information. So all of that will just automatically format for me. And then this happens to be a horizontal list, but what I've done is I've actually increased the size of the images, and as you can see, everything automatically adjusted for me, so you don't have to worry about that. What you get at the bottom here, we find customers really like this on the Echo Show. These are hints. And for those of you who have an Echo Show device, you've probably seen this. You walk by the device and it's like, try saying this. So you find out new things just by walking by the device. And I figured out some neat things that I could say, Alexa, like how you doing today, and she actually gives you some information. It was neat. So you can do that with your skill as well. So if I say Alexa select number 1, it would mean this one here. And obviously, you want to use numbers from a design perspective because I don't even know how to say that cheese for number 2 there. So I'll just say select number 2, and then your accuracy levels will be much higher. Okay, make sense? All right, so let's have some fun here with the remaining time and try to build something. And if you're following along on the YouTube video, feel free to go ahead and do this at home. Everything I'm going to show you is in the free tier, so if you go to developer.amazon.com, and let me open my pointer for those at home. Okay, and then we're going to click on this Amazon Alexa. This is where you can go ahead and set up a free account. Now, I know I'm at an AWS conference, so I am going to use AWS Lambda as the cloud service endpoint. And the reason all of this isn't in your AWS dashboard is this is the SDK for Alexa that's working in the devices. So if you're using like Lex and Poly, yes, you're using the Alexa NLU underneath the cover, but that's exposed as an AWS service. So that's why you're going to see me jump back and forth through these portals. An easy way to remember it is developer.amazon.com is anything that Amazon offers that's not an AWS service. So it's all of our App Store stuff, all of our devices, our advertising networks, all of that. So we're going to go ahead and create a skill. I'm going to click up here, add a new skill. And we're going to say custom interaction model. If you haven't looked at Alexa skills for a while, these other things that you're seeing there, the ultimate goal is as Alexa learns how human beings ask for things, we'll go ahead and we'll just create that interaction model for you. So today we know how human beings ask to turn on lights, how they ask to change the temperature. We know how they ask for the news with flash briefings, and we know how they ask to turn TVs off and on and turn to channels, and that's why you see the video app. Because we're going to create this trivia about space, obviously she doesn't know how to do that, so we're going to say custom interaction model. Now, we need to create an interaction model for each region that we're going to make this skill available. And you can see here, currently at the time of my session, these are all of the regions that are now live for Alexa skills. So I'm just going to say US. I'm going to give it a name, and we'll just call it example trivia, I guess. Now, invocation name and name, if you haven't done an Alexa skill before, just hop on over to Amazon.com. Skills. And this is where you'll be able to peruse all of these thousands of different skills, and you get an idea of what other people are doing. You can look across category. This one looks like it's got 2,600 Amazon customer reviews. And this right here, this is the name. But like, I'll give you an example. My last name is Bitsky. I could put that as the name up there, but I wouldn't want all of you have to say that every single time. So I may say Dave's Trivia, right? So you don't have to make it the same. You can see this skill is making it the same, but it's completely up to you. I'm going to make it the same because this is a demo. So I say example trivia. Those supported interfaces I talked about right here, that's what these global fields are. So do I want to support audio, video, or these new display templates? We're just going to make a simple one for now that works on normal devices. So we'll say, just keep it all to no. And you'll see I get this nice little green checkbox. We're going to go next. And we're going to move from this interface into the world of modern web development and get the nice skill builder interface. Yay. So up here, you'll notice I have these 3 events. If you haven't seen that before, what we do at Amazon is, again, if we know how people ask for things, we're going to just do that for you. So we know how people ask for help. You know, Alexa, I'm stuck. How do I do that? Help me. How do they cancel or stop? People will say, Alexa, go away. Alexa, shut up, right? All that kind of stuff. I'm guilty of some of those. We know how that happens. So that Amazon help intent, stop intent, that's what that is. What I've done in order to save time is I have, yeah, that's big enough. This is what an actual intent JSON object looks like. You'll see I have the same intents right there, and then I've just created a new one called get new fact intent. So this will mean somebody just wants a fact about space. So we'll go over here. I'm going to paste it in, and you can get all this code online as well. We'll hit apply change. And you'll notice I have this neat new intent, and now it's in the visual tool here. So if you remember before when I talked about Skill Builder, I said you can work in the context of the conversation. So maybe I want to add, tell me something great. So you see how I did that? This becomes another example. Now, sample utterances, if you're a coder and this is the first time you're seeing this, you're going to be like, is this weighted? Is this enumerated in any way? Nope, we're actually teaching the AI what people are going to ask. So these, I don't know, there's like 10 of them here. These things will teach the AI how to handle 1,000 different ways of people asking it, okay? And because of that, what we need to do is we have to, ahead of time, build the model. So I'm going to go ahead and click that. Everybody see it's now building the model? Okay. The way this works underneath all the computer science is you have a model for the language. So we have a model for US. We have a model for my conversation, which is my skill. And then I have a model for me. So your voice profile, when you use your Echo, you speak and you do things differently than other human beings. You have your own model for that. And all of that works together so that Alexa knows what the heck you're talking about when you ask for something, right? Okay. So while this is building, because this can take 30 seconds to a minute, I'm going to jump over into Lambda. If you've never used Lambda before, don't worry about it. Just go under Compute and hit Lambda. It's a way to actually run code serverless without worrying about an instance or anything. I'm going to say Create Function. All of your Alexa stuff is under these handy blueprints. By the way, we are at an AWS conference. So how many people have used Lambda? Awesome. That number keeps getting higher every year. So what we're going to do is we're going to take this first one. We're going to say fact skill. All right. And we'll call this example trivia. And this is just IAM permissions. So if you've used any kind of AWS services before, you'll know about IAM. I'm just giving it basic execute permissions. This code here, if you have used the AWS SDK, so in Lambda, if you want to call out to DynamoDB or any other kind of services, we have one for Alexa. So it's the same thing, require Alexa SDK. And just like the AWS SDK will wrap services into nice, handy little libraries, we do the same for you. So we're going to encapsulate a response object, and we're going to send you in the request a language ID. So everybody see this? English? So this is how easy it is to have Alexa speak back in different languages. So you can see German, I have English GB, and so I'm just replacing random facts. Now you could pull this from a database, you could pull this from another service, whatever you want. It's just hard-coded in here as an example. And then here's our helper functions. The way that the Alexa SDK works is that you have handlers. I have handlers for the different intents, and all of them are going to call, for this example, they're all going to call get fact. And you can see we get a random fact, and then we're going to go ahead and we're just going to build this string. Now, you remember Eric talked about how they borrowed ask and tell? So the nomenclature inside the Alexa SDK is if I tell something, I close the session so you don't see the blue light on your Echo. And if I ask something, I keep the session open because I'm waiting for a human being to give me more info. So what we're going to do is we're just going to tell with a card. And a home card will just display information. It doesn't need a device with a screen. It's not using any fancy render templates or anything like that. OK, and then if we ask for help or cancel, we're just going to show those messages. So let's go ahead and create this function. Now, when you do this, if you try and run this from Alexa right now, because you need a secure connection to call into Lambda, we're going to use triggers. So a lot of you are familiar with triggers. So you've probably done this for other services. The Alexa one is right here. We're going to say Alexa Scales Kit submit. And I have my nice trigger. I'm going to pretend for purposes of this demo that I'm a good coder. So I'm going to go ahead and configure a real test event. I'd normally just go ahead and push to production if this was my own skill. And we're going to go ahead and say get new fact, OK? So that's our intent. So I'll say Alexa intent, get new fact. I'm just going to call this intent request. So this is what Alexa would actually send our service. Everybody see it's just the JSON object. I'll have a session ID, application ID. See here it matched on an intent with that locale. So we know it's English US. It's get new fact. So Alexa knows to call that intent. And you'll notice here supported interfaces is a zero-length string. All right, so there is no display. So when I run this, It should not use any kind of render templates. It should just assume it's just a normal display. We'll go ahead and test. And you can use any language you want. Like you could use TypeScript too, like Eric talked about. You see here, this is all you're going to send back to Alexa. So you're going to say, Alexa, say this, which you can see right here. So she's giving a fact. Here's your fact. And display this card, close the session. Make sense? OK. So we're going to copy this ARN over. We're going to go over here and test. And it should have built. If it's built, and you're doing this at home, you should get this nice green checkbox. So we're going to click on Configuration, and we're going to put in an ARN here. We give you the ability to do geographic endpoints too. So if you want to have your skill available in Japan, and you want to use Lambda over in one of the different geographic regions over there, or in Europe, if you want something in Dublin or something like that, you can too. I'm just going to say no for now. We're going to leave the rest blank. We're not going to use any of the other features I talked about that have launched, like device address and the lists. Okay, and I'm going to go ahead and click Next. And you'll see I get a nice green checkbox. Now, I have Ask Example Trivia. And what I thought would be neat is to kind of show you the simulator here. So if you don't have an Echo, don't worry. You can go ahead and you can use this free tool that we have here. All right. And let me increase the font size for all of you. Is that better? Yeah. OK. Now, I can pick different languages here. So you know, obviously, I don't have an Echo in Japan, but if I switched over and I wanted to deploy a skill in Japan, I could do that, and then I can talk to it. Konnichiwa.
Konnichiwa.
And so you have the ability to do all that. We can even tell jokes across. So if I pick over here, English, India does both Hindi and English. Hello, tell me a joke.
Did you know that Death once had a near Rajnikant experience?
And they're just as corny jokes in all of the languages, trust me. I'm going to go ahead and do US, because we've only done the skill in US. And this should work if we do what it's telling us here, ask example trivia, right? So if I say, ask example trivia for a space fact.
Here's your fact. The Milky Way galaxy will collide with the Andromeda galaxy in about 5 billion years.
OK, so we don't have to worry about that just now. But that shows you that this is live and it's all running. Now, what we've done in the developer console is we've updated this service simulator here to be an Echo show. Everybody see that screen? So even though this skill is a voice-driven experience, right? There's no screen information. If I run it, this Ask Example Trivia, so you can see this button, Ask Example Trivia, and I say, for a space fact, you'll see it actually displays the home card. So this is what that Echo show would look like at home. Now, it's not using any of the templates. As you can see in here, this is a real request that you're seeing over on the left. You can see the supported interfaces are blank, and I'm giving a nice normal response. Okay? So you got that skill, it's out there, it's certified, it's running on your customers' devices, and now you want to update this to detect if it's screens, but only keep one skill that will dynamically generate visual information if it finds it. Okay? So the way we're going to do that is we're going to come up here to skill information, and we're going to turn on those render templates. Everybody see that? So I'm going to hit yes. Now when I hit next, this is the cool part, we'll jump right in here and boom, you're going to get all of these different events. So these are all of the events I talked about where a human being can say, Alexa, show more, Alexa, scroll down. They don't have to necessarily touch, and it will handle both of these, okay? So we're going to save, and then remember, this is a model that needs to be built, so we're going to do build model. Now, the code to use the display directives, like you saw in Eric's code, they just encapsulated the templates. It's a very simple change. In fact, this is all that it looks like when you render, is we're going to add this to the response. So I'm going to say right here, display render type. You see this new directives section. Okay? I'm going to say it's a body template 1, and then I'm going to give it primary text, rich text, and a font size, and the template. This code, and you'll see this up on our GitHub, github.com Alexa as well. We also have 2 helper functions, so you can see this to see if your display. For those of you who are JavaScript and Node developers, you know the pain of getting zero-length strings and not always being the same. That's why you see me doing this big this big end. So if it sends everything it's supposed to, we'll finally get it true. And you can also detect if you're in the simulator. So if you want to put some debug code when you're in that Echo Show simulator, you can. So we're just going to copy and paste this, throw it in here. Run it. And you can see we got the nice normal execution of a response object, but what should happen now when we test this is the simulator should send us a supported interface of display. So we'll say for a space fact. And you can see right here, lo and behold, right down here, everybody see it? Let me use this on the screen. Supported interfaces display. So because of that, over here, we created a render template. And you can see font size 5. And because this is a template, I could come in here and I could actually increase the size. Eric talked a little bit about our sizes, how they were changing over time. 1 happens to be 32, 5 is 32 pixels currently at the time I'm doing this. 7, I think, is 64. So if we do that, we rerun this. Everybody see it's bigger? All right, so last thing, let's say we want to do a neat image with that. So I have this image. The screen on the Echo Show is 1024 by 600. This is the Andromeda Galaxy. You can pull any image you need up here. What I've done, same exact code, one tiny little change. We're going to add a new attribute called background image. So you can see up there, background image source. The source is an S3 bucket. If anybody's watching this, I'll keep my S3 bucket live for another week or so before too many people hit this YouTube video, but if you want to check it out. The only thing you need to do, if you've used S3 before, make sure it's a public bucket and make sure it's everyone read permissions. Okay? Or you could put it anywhere else that Lambda has access to. So we're going to bring that over here. What's that? No, you don't have to worry about it. I'm just calling straight into the S3 bucket. You don't have to enable cores or anything like that. You do have to for audio, though. The question was around cores and cross-domain. Audio, you don't. Images, you don't. You don't have to worry about it. Audio, you do. Images, you don't. All right, save and test. And you can see, just normal for people who have a regular Echo, and for people who have a screen, yay, we get the cool image, right? So using the templates, we hope to improve upon these templates even more over time. You have the ability to take your existing skill and just start to delight customers by adding some additional graphical information in. Pretty cool? All right. Well, thank you, everyone. That is ALX317, and Eric and I will be around if you have any additional questions. Have a great reInvent. Thank you.